Hey everyone, this is Randolph Parker MS. Welcome to my channel. Today's topic, we're going to discuss the common failures to a switching mode power supply. One of my favorite things to work on and to repair. Switch mode power supplies, as y'all know, are widely used in electronic systems due to their efficiency, but they can suffer from various common failures. Some of those common failures are capacitor failures, solder joint failures, semiconductor failures, and transformer failures, and overheating. Number one, capacitor failures. Over time, as you well know, they're mostly electrolytic capacitors through hole can dry out and leak, leading to diminished performance of total failure of the switch mode power supply. So when I'm troubleshooting, I look for those evidence of leaky capacitors, capacitors that's warped or bubbled at the top or on the side of the capacitors. I use my capacitor checker if I need to take it out the circuit, but for the most part, with switch mode power supply, you can just look at the capacitors and you can tell that they are physically damaged somehow. Common mistake of a technician is not giving bad solder joints or cracked solder joints is due. It can fix a lot of electronics, especially in the power supply repair industry. So solder joint failures can come is probably due to thermal cycling of the switch mode power supply itself, can cause solder joints to crack or fail. So it's very important to look at your solders under microscope, magnifiers, whatever you have, is to look at the solder connections to ensure that you have proper solder connection made on the power supply. I will reflow solder for the most part, and I got a power supply working again. It's back to life. It's that simple. Number 3 on my list is semiconductor failures. Of course, the active components like diodes, transistors, and other semiconductors can fail due to overheating or voltage spike. So again, common giveaways of that is to visually inspect the power supply to see burnt marks, smell. Use your senses, right? Use your sight. Use your nose. You can see and smell burnt components. Sometimes a rule of thumb, when you see a MOSFET transistor or something burnt out, you look at the schematic. You try to change those components in line, because a spike can potentially have weakened other components down that line. So it's really important to look at the schematic if you have one, or one is available for you, to check those other components. Fourth, transformer failures. Now, on average, I don't do a lot of power supplies. This is my own personal stuff I do in my shop, whatever. So it's not like I have tons of power supply just flowing in, but on average, if I do get anywhere between 5 to 100 power supplies a year, I would see probably 3 to 4 transformers that's bad. Most times, if a power supply is well designed with a good transformer, it can probably be safe to say that they're pretty good. But you do get failures on transformers as well. So don't overlook the possibility that you have a bad transformer. If you don't have the right proper desoldering station, I got a solder iron I call Big Bertha, where it's bigger in surface and diameter to provide a lot of heat to those solder contacts to remove the solder, remove the transformer off the power supply out of the board. So it's a pain to have to remove the transformer out to check it outside the circuit sometimes, because you might have to do that occasionally to really get a good reading. But check the windings and stuff like that. But it can be a pain. Again, so issues with transformers such as shorted turns or open windings can lead to loss of power and efficiency. So look out for that. And fifth, on my top 5 for now, I might create another list for top 10, top 20. Right now, my 5 things are overheating, lack of proper cooling, or thermal design defect, or not a proper design of airflow or air quality of a power supply. A nice fan. I remember when we were designing a power supply for one of the companies I worked for, and it was for a jet fighter, and the MOSFET would overheat, and we trying to figure it out. We was trying to figure it out. But long story short, the problem when the jet fighter will go up 20-30,000 feet in the air, the fan that we chose was not efficient because the air is thinner. But when you have it on at ground level, you troubleshoot and you can't figure this out. And so we had to pick a larger, not a larger fan, but a fan that can draw more current and more, because the air is thinner, and allowing proper cooling. So I remember that was like 20 something years ago. But yeah, so overheating, lack of proper cooling, and thermal design can cause components to overheat, leading to failure. So those are my top 5 failures that I find in a switch mode power supply: capacitor failures, solder joint failures, semiconductor failures, transformer failures, and overheated. This is Randolph Parker, MS, and I will see you on the next video. Thank you.